Cool, so I'm Anna, I work at Hive as a developer. We do quite a lot of different things, but I'm a huge serverless fan. I've been working with serverless for the last 2 years, and I have been talking about the serverless framework, how awesome it is, and about how you can write plugins for it, etc. But over the time, I also assembled quite a lot of experience of when things go wrong. And I thought it was quite interesting to talk about a little bit what do you do when things go wrong with serverless and serverless framework. So this talk will be at first a little bit why we decided to use serverless and what for, and later on about the hurdles we experienced and how we got over them. So as Jamie mentioned, here at Hive we have an ecosystem of smart devices. We've got quite a lot of thermostats. I think there are 4 different types. We've got 3 or 4 different sensors, 4 light bulbs, some smart plugs, we've got cameras, hubs, quite a lot of different types of devices and models of them. But on top of that, we also support actions so that when, let's say, you open a door, a light bulb might turn on, or we support schedules so that you have your home nicely warm by the time you come back home from work. Or you can turn on mimic mode on your light bulb so that it kind of looks like you're at home although you're on holiday. And we've got third-party integrations and quite a lot of other stuff going on, which means that the system we need to work here with is really, really complex, and it's quite difficult to manage that level of complexity. In order to do that, we've got quite a typical infrastructure here, or architecture. We've got some hardware at the bottom, so those are the devices. Above that, we've got some API that controls all those devices. And on the front is the apps, and that's what we are working on here in London. And we've got a WebApp, we've got the iOS and Android apps written in native code, and then the React Native apps. So basically, we've got like 4 or 5 different front-end apps that we need to support at the moment. The difficulty is, as most people probably know who have worked on front-end, is that this API never returns us the data that we want. It's always some kind of data that is more geared towards the back-end than the front-end. And so, as most places, we decided instead of repeating the same business logic in all of our apps, we'll create an experiential aggregation layer so that we don't have to do that kind of hassle. And that's the one that I'll be talking about today, because that's the one we wrote in Node.Js and deployed as serverless. We decided to do serverless for various reasons. I don't know how many people here know what serverless is. If you can do a quick show of hands. Awesome, that's probably a majority. Who have used it in production? That's much fewer. And it's usually that way because serverless technology is still quite new. So serverless as an architecture concept is the idea that you can just deploy your function, just your code, and you don't have to worry about all the operations around it. You don't have to worry about containers, you don't have to worry about setting up headers for your requests and calls and all this stuff. You don't need to worry about load balancing. All you need to worry about is writing your code, shipping it somewhere, and saying when that code should be run. Quite typically, that is when you send an HTTP request. That's the most usual use case. And that's why most providers who do function as a service do also some kind of version of API. Here at Hive, we're using AWS, so we're using Lambdas and API Gateway, but there are many other providers who provide this kind of service. The reason why we chose serverless is because it's really good for devs. Most of us here are developers. We don't have a huge operations team. I think we have like one person who kind of semi-does operations. So we need to be able to ship fast and efficiently. We don't want to spend ages trying to configure the right CloudFormation setup. We just want to write code and really focus that the code does the right thing and it does it the right way. So serverless is amazing for that because it does all the management for us. We don't need to deal with the load that hits our services because that's what AWS does. They're really good at doing that, so we don't need to reinvent the wheel. They make sure that it's kind of managed on its own, all the containers, etc. We don't have to deal with that. Another great thing is that you can deploy the function separately. Normally when you have even microservices, you have to deploy the whole service at one point. But in a serverless world, you can deploy just one function at a time, which means that the risks that you're taking with your production code are much lower than you would normally have. Plus, it's really easy to use, especially if you use Serverless Framework, which is a tool that's usually used for deploying serverless architectures. It's a matter of writing a simple config and just shipping your stuff into production or wherever, which is really nice. So the amount of hassle is really, really low for delivering something that you actually want to write. And then it's also kind of fun because it's one of those semi-new flashy tools that everybody wants to use, so it's really cool that we can use it in production. The question, or like one of the first problems that we hit here at Hive is, how scalable is serverless? Because one of the advantages you'll always hear is it's infinitely scalable. Well, that is true, but there are different types of scalability. The issue is that it is infinitely scalable when it comes to the load. You know, you have 1 user, 100 users, million users, it doesn't matter, it handles it on its own. The problem is when you start writing large applications. In our particular case, we've got the experiential layer, as I showed you, which, I mean, really, you can't split that up in any meaningful way like you would do with microservices. You need to have basically just like a one thing. But that also means in our system, where we've got so many devices and so many different things to do with them, there's like quite a broad layer that we need to support. And that's really the problem that we were hitting a lot. Especially in the last few months as we were growing and adding new features, we were finding that that is something that is not very straightforward. We need to think about the number of resources, about the policies or permissions, about the config, because there's just one config for the whole service, but also about the file size of all the functions. There are interesting limits to AWS that we did not know about, and also they're kind of the limits you look at and you think, that's so much, we'll never hit that. Like 200 resources, you think deploying 200 resources to AWS will be impossible. We won't have 200 functions. The problem with serverless is it hides a lot of things under the surface, so you don't actually know what's happening. It turns out that for one function you need function resource, you need the API gateway endpoint resource, you need a log stream, and then the ability to write into it. So there are around four resources per every single function you deploy. So the moment we hit 50, 55 functions, we suddenly started seeing these things. We suddenly stopped being able to deploy, and we didn't understand why that was. And then there was another really bizarre thing. It turns out that AWS only allows you to upload 10 megabytes of policies or permissions. Again, you would think that's insane amount of characters. That's, permission files are just characters that say this function can access this log stream. There's nothing complicated about that. But if you have 50 functions and all those permissions going from one thing to another, it actually creates a lot of churn. And when I looked at the policy file that is produced by Serverless Framework, I was really sad we didn't name our service something really short, because that would make the count of characters much lower. Fortunately, the solution was not to rename the service. The solution was to use plugins. Serverless Framework has this amazing system of plugins. It sort of provides you with some basic functionality of being able to deploy your functions, etc. But it also is written in a way that allows you to basically infinitely extend the capabilities of the system and change how it works. Also, fortunately, it has a huge amount of people who love working out of hours, probably, and creating open source. So there's a lot of serverless plugins already ready-made that you can just plug in. The difficulty is to know which ones you want to use. I spent 3 weeks trying to figure out how to get over the limitations of the 200 resources, etc. And then it turns out that I just have to use these two plugins that allow us to define roles in a much more concise manner, and that will allow us to split the resources into different stacks. And they are already written, you can literally just plug that in. And that's true for most problems you will hit with the serverless framework and serverless architecture, that someone has already solved it. It's just knowing how to use the proper solution for your particular case. So in this case, we just used two plugins, and then we defined that we also want the permissions in a specific stack, and that was all that we needed to do. But it took 3 weeks to figure out what 5 lines of code to write. So I kind of decided to do these talks so that other people didn't have to deal with this. Another issue we started having was quite a strange one, really. when we started deploying functions, the average size was about half a meg on average. We know when you have a function and some dependencies, that kind of seems about right. But over time, the size started rising and rising until we got to 23 megabytes a function. And that just seems like a lot, no matter what. And it's difficult because you want to optimize your production code to be really fast and very efficient. And if you have a huge file size, that's going to slow it down. Well, we found out that something really weird is happening yet again under the hood. We're using WebApp plugin to package all our code as you do so that we can use Babel and the latest ES 2018, whatever it is at the moment. But that Webpack plugin by default packs everything together. It takes all your functions, all your dependencies, packs it together, and then it uploads it as separate functions, but it's always the same package and always all the functions. So actually, you have to tell it that you don't want that, which is weird because by default you would always want that. There is no case where you would not want that to happen. Apparently, the reason why they decided to do it this way is because it makes it faster to package it, which kind of makes sense. But I don't care that my code is fast deployed. I want it to be fast in production. But that kind of shows that the serverless ecosystem is geared a lot still towards prototyping, etc. It's possible, totally possible to ship things into production, but you need to know about all of these weird gotchas. So that's another one. And then the last one that I wanted to talk about in terms of sizing was the config. One nice thing is that you have just one config file where you write everything. But then also the downside is that you have one file where you write everything. If you have 50 functions, you will end up with 400 plus lines of config. That is really difficult to get your head around. But fortunately, although you have to use YAML, the serverless YAML is a little bit of a different style to normal YAML files because you can import things from all over the place. You can import other YAML files, but you can also import JSON files. So you can kind of mix and match and create your configs out of all kinds of things that are out there. In our particular case, we decided to define each function separately. So we would have a list of all the functions saying, so these are the capabilities of the service, but look into this particular file on the side to see how exactly it is defined. And then we would have this definition of the function. So another nice thing would be that we would have the definition of how to deploy the function next to the function so that you kind of have those things coupled. But you still have the advantage of knowing all the functions in the service from the main config file. Then another issue that we ran into was how do you actually run it? It's amazing that it's serverless and that you don't have to faff around with servers, but how do you run it locally? You can run single individual functions locally, that's fine. But if you have it as an experiential layer behind your front-end app, then you sometimes just need to spin it up and see how it works. Well, our solution was to put the server back in. It's serverless with a server. When we are debugging our front-end app, unfortunately there are no tools out there that you could actually use out of the box. There are some, but they are not maintained anymore. So we decided to write our own. So we wrote a very simple tool, just a dev tool, that allows you to take all the configs for all the functions that you have defined and just spin up an express server that sort of does that. The important thing here is that we did put the server back in, but it's only a dev tool. We sort of downgraded it from a production style of things that needs to worry about a lot of stuff to a super simple thing that only needs to worry about the fact that there are some endpoints that you had with some information and that runs some functions. So we kind of created a bit of a hack around it, really, but it was probably necessary. Despite all the problems that we've had with the serverless framework over the last few months, I would still think that it's really, really worth it. Because, yes, the tools are maybe not 100% mature, and there are hurdles that we will run into. But I think that's true about probably every single production system. The nice thing about serverless is that it takes the knowledge of engineers from Amazon or Google or Microsoft, and they deal with a lot of problems that otherwise you would need to deal with yourself. and you still can just run things really easily and you can focus on the code. So no matter what problems we hit with it, I would still say it's really worth using it in production. Thank you. And if you didn't know, we're hiring in Hive.
Questions?
Yeah, any questions? There are questions. I didn't. I'll get the second mic. That's a bit here. Hello. Yeah.
Hi. I know many people who switch to serverless with the hope that it will reduce the server bill. And for many people it did, but for some it actually increased it by an order of magnitude. Do you know for which cases it actually makes sense to switch to serverless?
Yeah, so yeah, you're absolutely right. It's not a silver bullet, and it's definitely not a thing that should be used just because it's out there. It's really good for things like the experiential layer. So in our case, that's a nearly completely stateless thing that just takes data from API, translates them, and sends them onwards. It's good for data processing. Generally speaking, it's good for things that don't need to be up and running all the time, that are really event-based. I feel like a lot of people, I've seen people who literally took Express Server and spun it up in a Lambda. And I thought, why would you ever do this? Why would you ever put a server into a serverless system? So there are definitely ways and times when I would say definitely don't do it. But I think generally speaking, when you have like a very heavily event-based system, that might be a good one.
So one thing I've realized from serverless is that it takes the problems from your code away, or many of them, and instead it puts it in your infrastructure. How do you manage the problems that the infrastructure causes as opposed to the code?
Oh, that's interesting. I always found it does the other thing round. Like, originally you would need to solve a lot of problems in your infrastructure, right? Like load balancing, etc. Now you kind of move it into configs and code where you have to deal with it there. So it's sort of like abstracted away. And I guess that's kind of what this talk was about. Like we solve different problems with code and with config. But I find that just reading, because it's all in Node, that's the lovely thing about JavaScript, you can actually read it, it's not compiled code. So I find it really useful to read through the source code of like the AWS CLI or the serverless framework. And I know it's a lot of work, but I find that really helps me understand what it actually does. I don't know if I answered the question at all, though.
Yeah, that's fine.
Yeah, okay. Yeah, there's one more there.
Thank you. Thank you for your talk. You talked a lot about optimizing your serverless code for time. One thing that I've noticed at some of the companies I've worked for is you have to optimize, especially AWS, a lot for actually money in terms of how much you're getting in terms of your bill at the end of the month from AWS. Even though your code may be amazing, it may end up using too many resources and you end up getting a huge bill. So how do you sort of keep track of that? Is there, like, does your boss suddenly get a bill at the end of the month and start shouting at people, or?
That's a really funny question. I don't know how much I can talk about this, but the serverless infrastructure costs us much less than the rest. So for us, the cost of the serverless infrastructure itself has not been a problem. I've heard crazy stories when, like, for example, if you create like an infinite loop with your Lambda and it just like the cost keeps coming, well, there are alarms at AWS. I know that they are slow, but that's generally speaking, that can be a problem. What I think is really good to do is don't ship it straight to production. Test it out beforehand, somewhere where you can shut it down really fast. But yeah, that's definitely a concern. I guess like setting up the right alarms for your company is really important, and making sure that you test out the code before you ship it properly.
And last question, we have very limited time, so one time to break.
You can always catch up with me in the pub if you want.
Hi, very good talk. I was wondering how you deploy. How do you make sure that the functional version is in line? Because I guess you talk about hundreds of functions. So I guess you need to make sure that whatever version of this function you're testing on development, on local, are actually one in production. How do you manage this deployment?
So the deployment is what the serverless framework does for us. So you can set it up in a very simple way. I think at the moment we have a manual for some reasons, but you can literally set it up with Travis or something like that, where if you merge into master, it automatically deploys it into production, and it's literally like one line of code, just, it's like SLS deploy, and that's all there is to it. So it's actually really easy to do that.
Thanks a lot, Anna.